Welcome. So, in today's class, we are going to be diving into exception handling, which is an important concept in programming generally, and it is also very, very important in um, Python for data science and analytics. So, we are going to be learning, uh, you know, how to handle exception, how to raise exception, and all of those stuff like that, and how to write clean code in a way. Like what we are going to be learning today is going to take us a step, towards writing clean code. So what does exception handling really mean? So you can think of it as the process of responding to runtime errors in a planned way, right? In a controlled way. So what actually happens is what this thing empowers you with is the ability to prevent your program from crashing. um from the way I like to put it is to allow your program from crashing from things that are usually not the fault of the way you've set up the program, but the way the fault of the data that comes into the program. That might look a little bit unclear right now, but you are going to see what I mean shortly. But you can think of it as a way for us to prevent program from crashing in a way that is not, programmers will say in a way that is not graceful, right? So, and here's the thing. Let me just like show you what I mean. So let's say we have a simple program, like the absolute simple program that performs division. So it takes, let's say we have it accepts a number, and let's make it a function. In the last class we learned about functions. So majority of the things that we're going to be writing today is going to be within a function, but you can do exception handling anywhere. You can even write it normally like the way we used to do things. But let's say we have this function that returns um let's say divide, let's say def, say write a function that performs division. Let's say that. Right. So if we come here and do def, or let's actually make it very nice and say write a function that gets the rate a pair of currency is trading at. So this function that we're going to be writing is going to return the rate that a pair of currency. So we can give it naira and dollar, and it's going to like do something under the hood and say naira and dollar is trading at this particular rate. So we're going to say def get rate, and it's simple. We can say base currency, or let's say first currency. Then we can go uh, second underscore currency, and then we can go on to the next one. But in the last class I taught you how to like annotate things. So you probably want to do float here. That is, this should be a float. And I like that we always do this so that we form good practice. So this is our way of saying first currency should be a float, second currency should be a float, and the output of this also is going to be a float. Then we can add, if we want, we can add some doc string here and say this function returns the rate which currency, which a pair of currency is trading at. Full stop. Then we can go on the next line. So how do we get that? It's very simple. We just say rate equals, or we can get which of the currency is greater. So that will make the work better. So we say uh if first currency is greater than second currency, then we can say greater equals first underscore currency, then else greater equals second currency. So this is the level where we check which of the currency is greater so that we can just do our quick division. Then here, the next thing that we want to do is we want to actually get rate. So we say rate, let's go and say rate, which is going to be equals to uh let's say greater. Okay, let's get actually, if we are doing this, we need to actually track both the greater and the smaller. So instead of working through this, don't let us like over engineer. So instead of doing this, we can come here and pass in, we can say greater currency, smaller currency. We can say greater currency, something like that, and smaller currency. That's going to be better. So we can just go ahead and say rate equals greater smaller currency divided by greater currency. Right. So now, if we come here and we return rate, good. So we can come here and say get rate of, let's say, $2,000, and that is one 2,000 naira to one. So it's going to return um 0.005. That is interesting. The first thing we pass in is, the greater currency is supposed to be the first one. So we can say 1 comma 2,000. Yeah, that is the perfect way to go about this. This is 2,000. So we are trying to say that we have $1, and we're given 2,000 naira for that. At what rate is that? 2,000. So if I should say, if I was given 15, like let's say $15, and for maybe 2005, maybe 25,000, and I run it that, so the rate is 166.67. So this is working basically. But what happens when we pass in 0 and 0? Yeah. So what happens if I should run this? It throws an error, right? And this error that it throws is not an error from the way my program uh is, because we've given it several uh data and it worked. But for some reason, when we give it 0 and 0, it didn't work, and which is a problem from the data that was supplied. Is that right? Because, well, 0 and 0 cannot divide each other, right? So another thing is, you might be thinking, well, can we just now write, if this is not 0, if that is not 0? you know 0 divided by 0 is not the only thing that's going to give you zero division error. I think n over 0 also. So let's say we pass 2,000 here. The greater one should be 0, then the smaller one should be, let's say we say 2,000. Let's say I was given nothing for 2,000 and I run this again. I should get that same zero division error again, because 0 over 0 is indeterminate, n over 0 also is indeterminate. So it is not like a thing where you can write if statement. What you want to actually do is do exception handling. You want to actually um r- expect this exception here, this error here. You want to expect it, and then when you see it, you don't want your program to break. You want it to actually handle it in a way that is very, very graceful. So how can that work? We can actually come here and say try, and that's the way exception handling work. Try to do this, right? Try to do this. Try rate equals to this, except, you know, we meet this error, which is zero division error. And what should happen if we see zero division error? Let's say rate equals, we just, every single time we see zero division error, we're going to return rate equals zero. And we can do anything. We can even return something like, let's just do rate equals zero. And we can actually run that and see. So if we run this now, we get zero, right? That is because we've already told this guy, like, if you ever come into situations where you have zero division error, just say zero. Then if we come here, change this to zero also, and run this, we also get zero. Meaning our program is not breaking anymore. Our code is not breaking because of zero anymore. We are now handling the error in a very nice and graceful way. So that is like the first steps to uh, exception handling. So basically, it is a thing of try to do this. If you're unable to do this because you ran into some type of exception, then do this other thing, right? So let's see another one. So I'm just going to show you the normal flow. This is just like the most used kind of structure is this, like for basic day-to-day Python for data analysis. But I'm going to show you the full scope, and this is important, especially in the case of data science, where you are getting into model deployment. You are using things like fast API, stream data, and stuff like that to wrap models into um, production environment, or even in cases where you are building when you are training neural networks, there are a few things that you want to try out. Okay, if this kind of data enters into this place, do not fail, because, well, failing like catastrophically is going to like be very detrimental. So you want to like you want to set up things that serve as a landing pad that saves you for when stuff like that happen. So let's see this kind of, let me give you the full uh say basic exception flow, or we can think of that basic flow of exception handling. So let's say what we want to do is we just want to do a normal division. We accept a number and we divide it. And once we divide it, we are going to return the output. So we say, excuse me, num, or let's say number equals, okay, let's wrap that in a try block. Oh, let's just try, like, let's start like this. Number equals, let's say float input. Let's take float, and we go input, say enter your number. So let's see whatever the number is, we are going to divide that by 10. So let's just say result equals maybe 10 divided by number, right? So if I should run this and give it 500, it works just like I've shown earlier. Oh, we are not printing our results. So let's just print result. Let's print result. And you can just print this without saving it in a variable. Anyone. So we're going to say 5,000 or 550. It says 0.2. Now if I should run it and give it um 0, we get an error, right? Zero division error. So now, which is kind of like what happens here. So this is just my way of, instead of wrapping it in a function, I want to show you the full flow, like how the full flow works. So the first thing that we do is we come here and we say try, then we tab all of this in, tab. Yeah, good. So try to do all of this, right? Except you are met with, like we saw, zero division error, right? And we can say print cannot divide number by zero. If we run that now and we say um zero again, it works. Now it's saying cannot divide by zero. And if I should run it again and give it 50, it does not impact that. Also, it works 0.2. That is, when we give it the valid thing, the try block, the valid data try block executes. We give it the invalid data that throws this particular exception, then this particular exception block executes. But then let's now try something new. Let's give it, well, we're saying enter your number here. This guy typed 52. 52 or 3, because I don't know why that is taking 3. So we say enter another exception again, which is not the same as we saw earlier. Earlier we were seeing zero division error. Now we are seeing value error. So we can go here again and have another except. So you can have multiple excepts. That's the whole gist. Except we go value error. Then we can print value input must be a number and not letters, or not strings. A string. So if we run that, say 3, and we run it, it says input must be a number and not string, right? Or we can tell them please enter a number, stuff like that. Then you can have multiple. Now, another thing that we actually want to do is, there's also, you can also include else, and else is important in the case where, imagine you are not printing out an output here. Let's say what we are doing is a database operation and stuff like that. And although normally you would log, there's something called login, but let's just keep it at basic. So let's imagine this program does not really print out anything, right? It just does something low key. And yeah, let's remove this print. And here, um, there's our try, there's this except that thing. So what you actually want to do is, sometimes you want to know whether things actually, like, uh, went through successfully. So you can add your else. It is in case like that you add else, and we go print operation successful, right? So if I should run this and I have 150, now I get operation successful, right? And if I had printed something also, I'll get that too. So if I should print result, print result, and do run it, I'm going to have enter your number. Let's see, for 3. It says this is the value of 43, then operation successful. If I should come here and run this again and say 0 and run that, it says cannot divide by 0. Hence, we didn't execute this block, right? Then if I should come in here and say enter your number and I say 15, and I run this, I get input must be a number, not string, and I didn't get this else block. Like, so this works in scenarios where you are maybe not printing out things in the try block, or you are not logging things out, and things are just going silently in here. Maybe it is some process that um, passes data to another object or stuff like that, and you want to see that everything actually went very well. So the way to do that is going to add the else block that shows you that things went the way they should, like everything went perfectly. Then the last component of the exception flow is the finally. So we can come here and say, let's say finally, finally, and print execution flow completed. So if we run this and go, let me give you zero. Try type zero first, and now we see cannot divide by zero execution flow completed. Earlier with else we didn't get this block executed. So anything that I do within here, whether I give it the correct thing, let's say I give it 12, I'm still going to get execution flow completed and operation successful both, because else is going to get triggered if the try block gets triggered, and anything that gets triggered at the top here is going to trigger this finally also. So if I should run the one for value error and give it 3, I'm still going to get input must be number execution flow completed. Now, why is finally extremely important? Finally is extremely important in situations where you want to actually do some input output kind of thing, and you need to like do some final thing. And I'm going to refer to databases again. So let's say you open a database inside a try block or anywhere else, and you want to, when you are done, close it, or even if it is a text file, anything that you open, it is best practice that you close it. You are not going to be able to do that with the else block if your try block did not execute. So the important thing is to find a way, a place where regardless of anything that executes, we can, do some final operation here. So that is where the finally thing comes in. And you're going to see it like prominent, like a lot more time in the finally uh in input output operation. So that is the entire flow. But you are going to actually really, really, especially in the case of data, like Python for data, you're going to be seeing try except more, like a lot more. And finally, and else are just very, very well, they work also. So that is a case of multiple exceptions. So if you want to add that to something like this, for example, if I should put 3 here, string 3, yeah, I get the error from earlier. So I can, pass in another except in this place to capture that. Now, how do we now? So this is the error here, type error. So I can actually add the exception here and say except type error, type error. Then I can say print, and let me even use the opportunity to show you this. Print cannot, input must be a number. Now, if I should run this now, it says, what's that? Cannot access. Oh, yeah. This is very, very important. Now, let me explain this. I'm even glad this came up. Our rate here gets created in the try block. And when we ran this, we gave this guy 3, this string. The try block didn't get executed at all. Like the try block didn't get executed. So what happened? What happened is that when we got to return rate, it didn't have anything to return because rate has not been created. Is that right? So what we can do, which is like a very, very nice thing to do, is come here and say, we start by saying rate equals to none, and yeah, we really don't even need to return 0 if we want. Like we don't need to return 0. So what we do is we just come here and we can print um currency value. Say value must be greater than 0, or you might not even add anything greater than 0. So if I should come here now and run this, it says input must be a number and nothing else. Is that right? Now, if I should check the type of this one, it's going to be a non-type. So if I should come here and say or let's say answer equals this, then I come here to get answer. If I should run that, now it says, or let me print answer. You're going to see that it's going to be non-type. I don't know if you can print non-type. Yeah, so it says none, and without throwing an error, because we firstly set up like a placeholder, like a container, for in the case that rate is not properly passed in, or one of the currencies not properly passed in, we just tell them what we want to tell them, and we return a non-type for them. So that's something like this that we can do. Now, the next thing that we want to try is, how do we catch all exception? It is not really like a recommended thing, but because, well, it goes against one of the core principles of Python, which is that errors should not pass silently. Like, errors should not pass silently. So how does that work? Let's look at this. For example, in a case where you have multiple errors that could come up, there is value error, there is this error. Now, the normal thing to do um would be to catch them one by one. But if not, you can catch them together. And this is another example. So let's try our division problem again. So we can try. Let me just copy from the top here. Where is it? No, here. So I'm just gonna copy this. Control C. Then paste it here. So we have tried, we get our number, but instead of doing zero division error, we are just going to be capturing all the errors. So there is a Python object called exception. So we say except exception, then print, because we don't know which exception is going to be. Let me actually show you this. If I should run this and give it zero, well, it's correct. It says cannot divide by zero. But let's run this again and I give it three. Sorry, and I give it three. I don't. That's input is always going to be a string. So if I should give it three, it's still saying cannot divide by zero. Meanwhile, the error that I have is not a zero division error, right? But that's because what I told it. Yeah. So I can tell it some error occurred, which is going to be the true thing, because some error occurred. It could be a type error, it could be an attribute error, it could be a value error, it could be zero division error, any kind of error. Says some error occurred. Fine. So if we run this, we say enter your number and we give it 3. It says some error occurred. If we pass in 0, some error occurred, because we are capturing all of these exception. Any type of exception, just capture it this way. Now, this is a problem, because, well, it's just going to pack everything together and just be churning out some error code without us actually knowing which error occurred. So in this case, what you want to actually do is um you want to actually raise, we are going to get to raise shortly. Then another thing is that you might want to like add the error, so you can say except, let's give this exception an alias. You can say except exception as E. Then we can add f string here and say f string some countered error, some error occurred. Then we can say full stop, maybe error detail. So we can go E like this. So if we run this and check 3 now, so it says some error occurred. Error detail is this. Let me add this one here. So error is that could not convert string to float for 3. So if I should run this again and I give it 0 and I type enter, it says some error occur, detail float division by 0. Now this is telling you what happened, like differently. This is it's telling you what happened. But then it is not telling it to you the way Python always tells it to you, like even showing you the line and all of that stuff. So what you can also do is you can actually raise the error. if you want. And that is for situations where you don't want the error to pass silently. For example, you will get it. It is something that happens a lot when you are working with pipelines. Also, you just don't want things. For example, if the error, let's say, yeah, you are wrapping this function, this get rate function, you are wrapping it in another thing, and you know this get rate function is working in another system. If you are doing some maths on the output of get rate results, excuse me, that particular place you're going to have problems there, because in situations where you do not have um the correct output, that is in situations where get rate returns none, there's a problem. You cannot perform mathematical operations on none, so the program is going to go fail in that place. And if you have an exception handling also there that you don't define currently, it's going to pass silent in that place and just keep going, and you might not be able to trace it to where the problem started from. So what do you want to do in that case? In that case, you want to actually raise all of those stuff. So you can raise E. So if we run this and we give it 0 and we run that, and it is going to raise the error, like we are forcing it to like raise the actual error that happened. So yeah, but a cleaner, better way of doing it. So it says float division error, float division by zero. I'm sorry, zero division error, float division by zero, and all of that. Just because we raised the error, just because we included raise E. But let's, apart from including this raise in a try block, we can also in an exception handling, we can also raise errors within conditionals, like things that are not really um Python exceptions, like they are not Python exceptions, or we are not letting it get to Python exception. What do? We raise an error. So let me show you how that works. So for now, let me remove this so that we can have a cleaner page. So here, let me come to this place and say, hmm, let's think about it. So let's have a function called divide. So let's say dev divide, and it's going to be num1 comma num2. And again, you should always do type annotation and stuff like that. So what we want to do is, we want to divide every time. We want to divide num1 by num2. So we know that it is num2 that should never be zero, right? Because zero over something. Let me show you what I mean. This is what I mean. If I should come here, if I say uh 0 divided by 2, that is going to work. That's going to be 0, right? But what will not work is for 0 to be in the denominator. For example, 0 divided by 0 is not going to work. Then 2 divided by 0 is also not going to work, right? Great. So we want to make sure that this is not, 0 is not in the denominator. So we can come here and say if num2 equals 0. So we don't even need Python to get to the part where it is going to know. We just automatically do what? Raise the exception by ourselves. So we say raise, and we know the kind of error that this is going to be, zero division error, and we can pass in the detail, like I say detail, or I don't know if detail is what it takes, but you can just pass it in straightforward. We can say denominator, or we can say num2, value of num2 must not be 0, of num2 must num2 must not be 0, right? Then we can now come here and say return, that is we do our normal stuff, return num1 divided by num2. So good. If I should call divide and I say 2 comma 5, it works. 0.4. If I should do 2 comma 0, look at what's going to happen. We get zero division error, but it is not your type of zero division error that you are seeing, which is division by zero. This is the normal zero division error, division by zero. In this case, we are actually the one customizing the error. So we are saying value of num2 must not be zero. We are the one raising this, like, yo, you cannot make value of num2 less than zero, equals to zero. So that is that. And we can raise multiple ones. So we can come here and say if is instance, then we can go, sorry, and see if not is instance num2, and that is going to be, or we can, I don't know if we've seen, I don't think we've touched on is instance before. And these are, let me show you how it works out of here. So let me just put that here and say it's just a way of checking if something is a type of the other thing. So we can say is instance, then we can go 45 comma int. So it's going to return true. If I say 45.0 comma int, that's going to be false because 45.0 is float. So I can come here and say float. So it is our way of just saying type 45.0 equals float. So that's is like the same thing, like this. So in this case, another one I want to check is, we want to check if not num2 is integer. That is, if num2 is not uh, uh, integer, then we raise an exception. So we can come here, and in this case we raise, that's going to be type error, right? So we can say of value error, and we say num2, sorry, must be an integer. So if we come here and run this, it says zero division error, but if we change this to 3 and we run this place gets executed. It says num2 must be an integer, right? Because then it is not an integer, and it applies to even when we say true. As we come here and say true, which is a boolean. So we come here, yeah, boolean. That's interesting. If you come here and you say true, and you say int, if we come here, it says true. Why? Because true is basically one, right? True is basically one, and that's the reason why you can do true plus true, and it returns 3, right? So it returns 3. So Python treats this guy as, can also treat it as an integer, like this bool guy. So if I run this, I still get true. So that is that. And you just really want to pay attention to all of these things. So this is the way we raise exceptions, the way we raise errors and stuff like that. And I've shown you earlier that you can raise exceptions within um, a block, also like within an exception block, and that is extremely important in situations where you do not want your error to just pass silently. So the last time we're going to be looking at is how to define a custom exception, like how to create our own exception. So let's say uh we have a system where, or we have a program where, if you have a negative number, a negative input, it creates a problem. For example, in the case of currency conversion, you don't want um, to get negative. Why would anybody want to convert negative values, right? So what you want to do is, and this is something that would make more sense if we've covered OOP, but OOP is two classes away. In the next session, we are going to look at lambda functions, and after that, we are going to get into OOP. But for now, let's just look at this very simple thing. So we can define, let's say, custom exceptions. So let's say we have a class. This is how we create. In fact, things like int, int, float, all of those stuff. There, all of them are objects. Every single thing in Python is an object, right? And you're going to be learning more about that when we get to object-oriented programming (OOP). But for now, you can think of class as the blueprint of an object. So we are going to create this custom class for now, but don't worry too much about it. When we get to OP, you are going to get it, and I'm going to make it the simplest thing. So we're going to create this negative number error. So this is an error that's going to always come up. It's going to inherit exception. That's our exception class that we're using earlier. So, and one of like the important concept of OOP is inheritance. You are also going to learn extensively about that. So, like I said, don't worry about it also for now. So I'm going to pass. That is, we are not doing anything in there. That's all we are doing. So let's say we now have this very simple function that checks whether a number is positive. I'm making this because I don't want to go extensively into writing the um, currency converter kind of thing, but this is something that you can incorporate into a currency converter. So we say check if number is positive, and it's going to take the number. And what happens is we are going to say if number is less than zero, that is, if the number that this person passes in is less than zero, that means that's a negative number. We are going to raise this, our new type of error that we have now, which is raise negative number error, and we're going to say value of currency or value of number cannot be negative. Good. So if we come down here, you can actually say check positive, excuse me, and we give it -5 as the number. So what do we have? We have negative number error, and it says value of number cannot be negative. We can also add that in a try except block. Like this is a valid this is not a valid error that we've created. Like this is not a valid custom exception that we've created. So we can come here and say, I don't know, let's go copy one of these guys that we have. Good. Let's come and copy this. Let's just copy this try block alone. Then we come, sorry, excuse me, we come all the way back down here and we say try to do all of this except what's the name of our error? Negative number error. Negative number error as E. Then we can print a countered error. Then we pass in E. So we are going to add F here, our F string here. So to actually do this, what we are going to have is we are going to say result equals, instead of doing 10 divided by number, we'll just say result equals check positive, and that is going to be of number. Great. So if we come here, this thing is not actually returning anything. So let's come here and return. Let's actually return something. So we can come here and say decision equals none for now. So we are going to return return decision, just to be able to have something. Right. So if we come here now and okay, I don't think I've run that. So if I should run this again, I get that error. And if I should give you something normal like 10, it returns none. Perfect. So if I should come into this particular place and run this, and I give it -5, and I run that, it says a counter error, value of number cannot be negative, which is, let us give it, let me come here and give this one -10 so that you understand what it means. So can you see here now, this particular value of number cannot be negative that we are finding, exactly that is what this guy is printing out here for us. Value of number cannot be negative. And if we want, we can also, after printing or maybe not printing, we can actually raise the error itself. We can say raise E, and we run this. If I should give it -5 and run it, it's going to actually print out the negative number error that we've created, which says value of number cannot be negative. So that is basically the entire basics, fundamentals of exception handling. And we've covered the try block, which wraps the code that might raise an error, which the correct code that has the ability to raise an error, like our actual business logic, goes into the try block. Where is it here? Yes, this is the try block. The actual business logic that has the potential to raise an error goes into the try block. Then the except catches and undo this specific error that we want in case of this kind of implementation, or in case of institutions where we want to just do multiple exception altogether, or generic exception, we use the exception class. Then the else runs only if the else runs and executes only if the try executes, right? So if no error occurs and the try goes well, else um executes also. Then finally runs when everything is done. Everything in here, once they execute, any which one that executes finally runs. And I mentioned that we use it for cleanups. You're going to see a lot of application of it in input output operations, in database operations and stuff like that. Then we moved on to understanding um you know how to do multiple, if exceptions. I showed that, which is except. Then we now got to raise, how to raise our own errors. Like even without doing try except, we can actually raise errors ourselves, and wrapping that inside conditionals. So this is how we did that. And instead of just printing zero division error, cannot divide, no, we actually tell them, okay, you cannot do this thing, this particular kind of data cannot come in. So that way we understand the actual problem that is happening. Then the last thing we now checked is, we looked at the way for us to create our own custom exception by creating an object that subclasses the exception object from Python itself. Then we look at how to actually raise that, and it behaves exactly like a normal exception would. So that is that on exception handling. You're going to be seeing a lot of application of that when we as we proceed. So thank you for tuning in. See you in the next one.